Hi students, today let's do two important questions from the chapter Motion in One Dimension of class 9 icse. Okay, the question says a spacecraft flying in a straight course with a velocity of 75 km per second fires a rocket motor for 6 seconds. At the end of this time, its speed is 120 km per second and in the same direction. So we have to find the average acceleration of the spacecraft while the motor was firing. And second part is the distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started and the motors were in action for 6 seconds. Okay, so let's look at the solution of this numericals. Let's see the given data for the first part. So now we know the initial velocity of the aircraft is given as 75 km per second. And the final velocity after 6 seconds is 120 km per second. So the time duration is also 6 seconds. So we can say T is 6 seconds. So this is our U, 120 km per second is our V, and we have T as the 6 second. Okay. So now let us use the equation V is equal to U plus AT. So now V is 120, initial velocity is 75, plus we need to find the acceleration and time is given as 6 seconds. So what we'll get? 6a will be equal to 120 minus 75, which is equal to 5 and 45. So acceleration is 45 divided by 6. So this is 15 by 2, that is equal to 7.5 km per second. So now we have the solution for the first part. The average acceleration is, so acceleration is 7.5 km per second square. Okay, now they are asking the distance traveled in the first 10 seconds. So the second part is we have to find the distance traveled by the aircraft in first 10 seconds. Okay. So now this first 10 seconds includes the previous 6 seconds when the rocket motors were fired, isn't it? So now we'll divide this into two parts. So we'll take the first 6 seconds and then we'll take the second 4 seconds. So now total 6 plus 4 will give us the total distance in the first 10 seconds. Now for the first 6 seconds we know the initial velocity, that is u, was 75 km per second and the acceleration was 7.5 km per second square. So now let us use the equation s is equal to ut plus half at square. Now t is 6 seconds here. So now let's put the value. So this will become initial velocity is 75, time is 6 seconds plus half, acceleration is 7.5 and then again time is 6 seconds, so we'll have t square here. So when we solve this, we will be getting, so we get 450 plus this is 135. So this becomes 585 is the distance. So the aircraft has traveled 585 kilometer in the first 6 seconds. Now we need to find for the first 10 seconds. So the remaining 4 seconds, now calculating for the remaining 4 seconds. So after 6 seconds the firing had stopped. So now the aircraft was traveling at a constant velocity and it was traveling at a velocity of 120 km per second and the time duration for which it traveled was 4 seconds. So the distance will be simply the velocity into time. So this is 120 into 4, that is 480 kilometer. So 480 kilometer was traveled in the last 4 seconds and 585 kilometer was traveled in the first 6 seconds. So now let's find out the total distance traveled in 10 seconds. So total distance traveled in 10 seconds will be sum of 585 plus 480 kilometers. So we are getting 5, 8 plus 8 is 16, 6 carry forward 1, 5 plus 4 is 9 and 1 10. So in the first 10 seconds the aircraft has travelled 1065 kilometers. So this is our answer. Now let's see the last question. So this question says a train starts from rest and accelerates at a rate of 2 meter per second square for 10 seconds. It then maintains a constant speed of 200 seconds. Then the brakes are applied and the train is uniformly retarded and comes to rest in 50 seconds. Now we have to find the maximum velocity reached, the retardation in the last 50 seconds, the total distance traveled and the average velocity of the train. Let's understand this by the acceleration time graph. So now the train starts from rest and it moves for 10 seconds with an acceleration of 2 meters per second. Then it maintains an uniform velocity for 200 seconds. Then the brakes are applied and it comes to rest in the last 50 seconds. Okay, so let's start the solution. So now let's take the first part, which is marked here. So train is starting from 0 and for 10 seconds it is moving with a acceleration of 2 meters per second square. So using the equation v is equal to u plus at. So now the initial velocity is 0 and it is moving with a uniform acceleration of 2 meters per second square. So acceleration will be 2 meters per second square and the total time was 10 seconds. So the velocity is 20 meters per second. In the second part, the train is moving at a constant speed of 20 meters per second for 200 seconds. Okay, so this is the constant speed part. Okay, now let's come to the braking part. Now the brakes are applied and the train comes to rest after 50 seconds. Okay, now let's see this condition. We will see the brakes are being applied. So when the brakes are applied, what was the condition? So when the brakes were applied, train was moving at a speed of 20 meters per second. So u is 20 meters per second and the final velocity is 0 because train comes to rest. Okay, again applying v is equal to u plus at. So we know the initial velocity is 20 meters per second. The final velocity becomes 0 and we have the a. Now this a will become the retardation and the time taken to come to rest was 50 seconds. So my time t becomes 50 seconds. So when we calculate this, we get a is equal to 20 by 50, which is 0.4 meter per second square. So now this a is basically retardation. As the train is slowing down and finally comes to rest. So this a will be minus 0.4 meter per second square for the third part. So we have got two answers. We asked about the maximum velocity. So we got this answer and the retardation in the last 50 seconds. This also we have solved. Now the third part is the total distance traveled. Okay, the total distance traveled will be the distance traveled in part 1, the distance traveled in part 2, and the distance traveled in the part 3 of the journey of the train. So let's apply S is equal to ut plus half at square for part 1. So S is equal to ut plus half at square. Let this be S1. So the train started from rest. So the initial velocity will be 0. And this is half. Acceleration was 2 meter per second square into duration. The time was 10 seconds. So this will become 10 square. So this is equal to 100 meter for S1. So we have covered 100 meters in the first part. Okay. Now let's come to the second part. Let the distance traveled be S2. So now we'll get S2 of the second part as, because it is traveling with a uniform velocity, so it will be velocity into time. So velocity is 20 meter per second and the time was 200 seconds. So time here is 200 second and velocity is 20 meter per second. So we will get 20 into 200, that is 4000 meters. So distance traveled in the second part is 4000 meters. So this part 4000 meters were covered. Okay. Now let's come to the third part. So let the distance traveled in the third part be S3. Let us use v square minus u square is equal to 2as, where here s is the S3, the distance for the third part. Okay, now we know the brakes are being applied here in this third part. So the initial velocity will be 20 meter per second, that is u. The final velocity is 0 because the train is coming to stop here. Okay. So now acceleration, we know, since it is a braking action, acceleration is negative 0.4. Okay. So now let's solve this by putting the values. So my v square becomes 0 and u square is 20 meter per second, so this will be 20 square. So it will be 0 minus is equal to 2 into negative 0.4. We can take this as S3. So we'll have minus 400 divided by 2 into minus 0.4 will be my S3. So let's solve this. So this minus minus will get cancelled. We will get 500 meters. Now let us add S1, S2, S3 and get the total distance. So our total distance will be S1 plus S2 plus S3. So which is basically S1 is 100 meter, S2 is 4000 meter. So this is 100 plus 4000 plus S3 is 500 meters. So this will become 4500, 600. So this is 4600 meters. So before the train comes to a standstill, it has traveled 4600 meters. So total distance is 4600. So this also we have got. Now let's see The last part, what they are asking. Now they are asking the average velocity of the train. Okay. So now we have to find the average velocity of the train. So average velocity will be how much? Average velocity will be total distance traveled by the total time taken. So total distance traveled, we know it is 4600 meters. And what is the total time taken? So see, we have it in the graph itself. If for part 1 it has taken 10 seconds, for part 2 it has taken 200 seconds, and for part 3 it has taken 50 seconds. So this is 200 plus 50 plus 10, that is 260 seconds. So the total time taken is 260 seconds. 260 seconds. So now when we solve this, we will get, how much we'll get? We will get 230 divided by 13. So this will be equal to 17.69 meter per second. So this is the fourth part. So this is the final answer. Okay students, I will end this session here. So these are the two most important questions which you should practice before your exams. If you like this session, please share and subscribe. Thank you.